Hi there, and welcome to the lesson which is on prime and composite numbers. So have your booklet open and a pen out. You can pop your calculator away because you won't be using your calculator, and get ready to take some notes. And make sure to listen to the audio because sometimes I'll be adding some extra points that you could maybe jot down as well. So first of all, prime and composite numbers. You might have heard of the word prime number, but have you heard of the word composite number? That might be something new that you'll pick up today. So how can you tell if a number is a prime number? I just want you to pause and I want you to write down your own thoughts to begin with. Just write at least a sentence on your own thoughts, and then afterwards I'll show you some other ideas too that maybe you could also add to your own thought. But first of all, just pause now and write your own thoughts. Okay, so now hopefully you've done that. Here are some ideas of what you could also use if you haven't already. I'll just click here so you get rid of all those things. So what some students have said in the past is some people say a prime number can only be divided by itself and 1. So a prime number can only be divided by itself and 1 is one way of looking at a prime number. It's another way. Some people have pointed out the only even prime number is 2. Like you'll see here, like if you look at all the prime numbers which are in green, prime numbers are in green, the only even one is a 2. You can see all the other even numbers are not prime. Next one. The only factors of a prime number are itself and 1. So you've already covered factors, so you should hopefully understand what a factor is. A factor is a number that divides evenly into another number. So a prime number, the only factors are itself and 1. Another way you could look at it is a prime number has exactly 2 factors. This tends to be the definition that I use. Sorry about the watermark, we just can't get rid of it. The prime number has exactly 2 factors, which is 1 and itself. So hence why 1 cannot be a prime number, but we'll get to that later. Another one, they must be whole numbers, so that's important. Prime numbers must be whole numbers. Can't be like decimals and fractions that are not whole numbers. Another thing, the factors must also be whole numbers, because by definition a factor is a whole number answer. So the factors must also be whole numbers. So feel free to pause and jot down any of these. And you can also have a look at the little chart of prime numbers over here. So notice as I said, the prime numbers are in green. The only even prime number is a 2, as pointed out here by a student once. All the other even numbers are not prime, only 2 is. So the first prime number is 2. 1 is not a prime number. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 58, 59. I'm not sure why these are kind of circled, so no need to circle these if it bothers you. Must have just been something I've done before. So if that's putting you off, we'll just uncircle that. And then so on, what are we up to? We're 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. So they're all the prime numbers from 1 to 100. How many are there out of interest? Let's see. You'd have to count. 1, 2, 3, 4. I'll get you to count up and write down how many prime numbers there are between 1 and 100. I'll get you to pause and do that now. Okay, another thing to think of is, you'll notice a lot of the prime numbers, a lot of them tend to end in 1 or 3 or 7, but not all of them. So let's see, why does 21 is not prime? Why is 21 not prime? I think that's right, because it's divisible by 7 and 3 as well as 1 and 21. Why is 51 not prime? So 51 is of course divisible by 1 and 51. What else is it divisible by that makes it not prime? So you might remember your divisibility rules. If the sum of the 2 digits is a multiple of 3, then it's divisible by 3. So 5 plus 1 is 6, which is divisible by 3. So 51 is divisible by 3 and 17, it turns out. 81, what is 81 divisible by? It's divisible by a number of things. One, for example, is 9. 9 times 9. It's also divisible by 3 because 8 plus 1 is 9, which is a multiple of 3. 91 is an interesting one. So 9 plus 1 does not add up to a multiple of 3, so it's not divisible by 3. but it is divisible by another number other than 1 and 91, another pair of numbers. So I'll let you kind of like have a little think of what it could be divisible by. And other ones, for example, 33 is not prime because it's divisible by 3. 63 is also not prime. 6 plus 3 equals 9, which is a multiple of 3, so it's at least divisible by 3. It's also divisible by 9 and 7 and 21. 93 is another multiple of 3. 9 plus 3 is 12. So it's not automatically not prime because it's divisible by 3. 27 is obviously not divisible. Not prime, sorry. It's divisible by 3. 57, what's that divisible by? I tend to look for multiples of 3 first. So 5 plus 7 is 12. So 57 is a multiple of 3 because 12 is a multiple of 3. 77, let's see, 7 plus 7 is 14. That's not a multiple of 3. So 77 is divisible by something else. You probably already realized it's 7 and 11. 87, let's see, what's 8 plus 7? It's 15, so it's divisible by 3. So there are good kind of ways of realizing why things are certain numbers are not prime. 99 is divisible by 9 and 3. 69 is divisible by 3. 49 is not divisible by 3 because 9 plus 4 is 13, which is not a multiple of 3, but it is 7 squared. So 7 times 7 is 49. So it's not a prime number, and so on. Numbers ending in 0 are not prime because they're divisible by 10. Numbers ending in 5, except for 5 itself, are not prime because they're divisible by 5. And numbers ending in an even number other than 2 are not prime because they're divisible by 2. So just little ways that you can kind of work out if numbers from 1 to 100 are prime or not. I tend to first of all think, is it an even number other than 2? Is it a multiple of 10? Is it a multiple of 5? Is it a multiple of 3 by adding the digits together and seeing if the sum is a multiple of 3? Okay, moving on from there. Why is the number 1 neither prime nor a composite number? So one thing you probably need to realize is what is a composite number? So a composite number, it's not all the red numbers. So the red numbers except for 1, the number 1 are composite. So try to think of, therefore, 4 is the first composite number, and then all the other red numbers except for 1 are composite. The green ones are prime, and the red ones except for 1, the number 1, are composite. So you might have already realized what a composite number is. If a prime number has exactly 2 factors only, 1 in itself, then a composite number has more than 2 factors, is a way you can look at it. So first of all, let's define what a composite number is, because you might have heard of the word composite number before. So I'll give you some notesies on that. First of all, a composite number is a number which can be divided by more numbers than just 1 in itself, is a way of looking at it. A number which has more than 2 factors is a way I tend to look at it. So, for example, 9 is a composite number because it's got more than 2 factors. It's got 1, 3, and 9. So composite number, basically I use the purple definition mainly, has more than 2 factors, but both definitions can help you have a good understanding of it. So why is the number 1 neither prime nor composite? So remember, a prime number has 2 factors exactly. A composite has more than 2 factors. How many factors does the number 1 have? That's right, the number 1 has only 1 factor. So I'll just scroll down so you can see it properly. Again, if you need to go back and take any of these notes above, just pause and go back. The number 1 has only 1 factor. So it is not prime, because it's not a number with 2 factors, and it's not composite. It's not a number with more than 2 factors. So feel free to write any other notes in, and also feel free to sort of try to get the hang of like which numbers are prime, because it's useful to know the prime numbers, especially you need to know these prime numbers. You'll be using those a lot. It's good to be aware of prime numbers that are a bit bigger as well. Okay, so thank you.